Hi all. In today's session, we are going to see a new different project, which is AQI prediction. AQI stands for Air Quality Index. First, we are going to install all the necessary uh, libraries. Here I have installed it everything separately using different cells, but you can do it in a single cell itself. NumPy, Pandas, sklearn, Matplotlib, Seaborn, etc. First, I have downloaded the CSV file from Kaggle. You can also find it there. See, there are around 30,000 rows in this data set, and the columns are like a city, date, then there are some measures like a PM2.5, PM10, NO, NO2, and for more details, you can, if you refer Google, you'll get to know about these measures. And finally, we have AQI and AQI bucket. AQI bucket will be our target. We'll see that in this video later. First, I have done this column printing thing, and using heat map, the null values are shown, and as you can see it here, there are so many null values in our data set. So first of all, we have what we have to do is we have to reprocess our data so that because with these many null values, if we train our model, it won't be effective. So data pre-processing is very important, and we are going to do that. So this project aims to predict and improve the quality prediction of a certain city's environmental attributes using the provided data set. And this data set contains various environmental parameters. Can you see? Yeah, these are the things. PM2, 5, PM10. So these are various environmental parameters recorded on a daily basis for different cities. You can see the cities here, different cities. It's Ahmedabad, Visakhapatnam. Since it is ordered from A to Z, it is shown like this, Ahmedabad, Visakhapatnam and all. If you want, you can print the unique values of the city column also using unique. And the goal is to pre-process the data, handle missing values. These are the missing values, right? So this is our goal, to pre-process the data, handle these missing values, and create a predictive model for quality prediction. So first of all, we are going to focus on data pre-processing and handling missing values in the data set using Python and popular data set libraries such as NumPy, Pandas, Matplotlib, and Seaborn. So as you saw earlier, we have imported all the necessary libraries, including NumPy, Pandas, Matplotlib, and Seaborn. And using this line, we have read the data set from the CSV file, and it has been stored in DF, that is data frame. This calculates, okay, this line df.snl this line calculates the sum of missing values for each column. And so these many missing values are present under each column. There are too many null values. You can get the shape of a data frame. These many rows and 16 columns are there. So to get the row, to get the number of rows, we have to call this index df shape of 0. And using this formula, we have just calculated this average value for all these factors, measures. And this is just a simple data analysis part. And here what we have done is we are converting the data type of date column to date time. So for that, this thing is available in pandas. So that's why we have mentioned as PD dot. And here we are setting the date column as index. In place equals true means the changes will happen in the present current data frame itself. I'll just tell you this point once more. This calculates the percentage of missing values for each column because we'll be using it to fill our missing values. So we are going to fill the missing values in numeric columns by using the mean of each city's value. And what we have done here is there are two ways doing this. First, so these are the numeric columns from PM2.5 to xylene. So using indexing 1 is to 30. So we are going to retrieve these number of columns and we are passing storing it in a variable called num. And using for loop, what we are going to do is we are going to fill all the null values with the mean value. So after that, we draw this heat map. As you can see, that null values have gone. So earlier it was like this. I'll show you. So these many null values are present in our earlier heat map, and now it has changed like this. We can also do like this just by dropping the city column, and if we find the mean value, we can get the mean value for these measures PM2.5 to 0, and we can fill all the null values using this field NA of mean value. So mean values will have the result of this line. So can you see both the results are same. And now if we see our heat map, the null values have reduced. Then what we have done here is we have to calculate this subindex. So for PM2.5, PM10, SO2, NOx, and NH3, the average value in last 24 hours is used with the condition of having at least 16 values. And for CO and O3, here, the maximum values in last 8 hours is used. And each measure is converted into a subindex based on the predefined groups. And sometimes measures are not available due to lack of measuring or lack of required data points. Final AQI is a maximum subindex with the condition that at least one of PM2.5 and PM10 should be available, and at least 3 out of the 7 should be available. So this is just a calculation. If you don't understand, you can skip this part, no problem. So these are the calculation part. O3 subindex calculation and AQI. I'll show this part for you. Okay, here we have retrieved the maximum value from each of these columns, and we have just rounded it off, and this equate column that also had some null values, so we are filling that null values using the rounded maximum value. So this is the result, and we have just printed the first 5 rows of the data frame. And if we see the heat map, now the null values in AQI have gone, and AQI bucket is, as I told you earlier, AQI bucket, it contains the target value. So this is the target column. If x is less than 50, that is the AQI value is less than 50, it returns good. And if it is between this range, it should display the satisfactory. And if it is between 100 and 200, it is moderate, and it goes on like this. If it is above 400, it is severe. So this is the AQI bucket values. So AQI bucket also had some null values, as you can see it here. So we are filling that using this line. And if we print a data frame, as you can see, AQI bucket, moderate. So this is the target column. And after we have done some reprocessing step here, so filling the null values of AQI bucket. And after that, if you see the heat map, all the null values have gone. So this has now become a quality data. And if we draw the heat map, you can see the correlation between the measures. And this is also some visualization part. The distribution of different pollutants in last 5 years. So each plotting is for each measure. And this plot is for average AQ in last 5 years. So last 5 years, so for different cities, we can see what the average AQI is. So Ahmedabad has the largest average AQI. Now what we are going to do is we are just going to take these two columns, and we are storing it in final_df, just these two, because if our AQI is more than this value, our result should be like this. That's how we are going to predict. So these two columns will be enough. If you print the unique values of AQI bucket, there are 6 unique values, moderate to good. And here using mapping, we're just converting these string to integers. That is, if it is good, that's 0, satisfactory level 1, moderate means 2, 4, 3, very poor 4, and severe is 5. After this, we are going to store this AQI column under X and AQI bucket under Y. And we are going to use random forest classifier. And here we are training our model, that is random forest classifier. And after that, we are predicting using this X test. And here we are asking the user to enter the value of AQI. And if the user enters his AQI value, that value is passed into this predict. And if the output, lies, uh, as you wait, I will show you. Okay. So if your value is below 50, it will give you good. Good is 0. And if your value is like, for example, 450, you have to get the result as severe. Severe means here it is. Severe means here it is 5. As you can see it at the bottom of the screen, severe is 5. So here I have given the value as 550. So that means it is showing array of 5, that is severe. And finally, I have this printer, this accuracy, classification report, and confusion matrix. So that's all. And the thing is, please make sure that you have a good understanding of the entire code and the data you're working with before using it in a real world scenario. You might need to adapt and customize certain parts of the code to match your specific use case. Thank you.